a lot of hard work. This one page that you just worked on is filled, absolutely filled with golden learning opportunities. Now, I know I sound like a weird math teacher, but there's so much going on here. I really could talk for the next 50 minutes, but of course I'm not about it. There's simplification of rational expressions that are being added or subtracted in number one, and the distributive property simplified. 2b is what we call a rational equation, which means it's an equation that has those funky looking fractions in it. Okay, there's a lot going on here. I asked you to look at 2b and compare it with page 2F, which is simply the adding of rational expressions, and explain the difference. You have this new idea here where instead of circling your answer like you've done in a zillion math classes before this, we're asking for a solution set. So there's a lot going on here. So I'm going to try to do this explanation. I'm not going to spend a lot of time going over this, because if you see in the first problem in our teaching demo is actually solving this equation. What I would like you to look at, however, right now, take a few minutes, look around the room and look how different tables approach this problem. So just take a few minutes right now and look at 2b and see if there's anything different between how you approached it and how another table approached it. Can anybody tell me overall a general strategy that it seems like or appears that every table used in trying to solve this equation? Yep, Parker? Right, so everybody looked at this equation, and you've been so well trained that when you add and subtract, things must look like. And when they're fractions, they have to be common denominators. So the first question I'm asking you is, are we simplifying an expression here, like adding and subtracting fractions? Is that what we're doing here? Are we adding and subtracting fractions or rational expressions? Are we or are we not? Is B like this problem? No. B, this is not like that. Why? B is an equation. You're being asked to solve an equation here, and what are you being asked to do here? Add. It happens to be what we call an algebraic fractions or rational expressions, whatever kind of fancy name you want to use. The idea doesn't change. When you're asked to add, things have got to look like. You have to create common denominators there. Otherwise, you can't do a darn thing. Here, you all have a choice not to do what you did. But because of your training, this is where you go. People change this so it had 12 on the bottom, so it's 3x plus 3 over 12. Nothing wrong with what you did. You changed this so it was 2/12. You changed this so that it was 4 times 2, 8 minus 4x over 12. No problem. What happens is sometimes students do all that work, so they end up getting something like this after they do all this changing of the denominator. And it always makes me feel so upset for you that you do all this work. Oops, sorry. I see this all the time, and then you even combine these numerators and get this. And then students stop cold there. They have no idea what to do with that. And that's the problem, one of the problems. One of the problems is that you're doing a lot of extra work, which we know in this day and age, our time's limited. You need time on your Facebook pages and Snapchats and all that. You got to, hashtag that the Patriots won last night. I know you're really busy. And then you get to something like this, and it's like, it's everything up to this point is fine, but you don't know where to go from here. Okay? So when you're trying to solve that equation, there's only one part to solve. There's only one part that is variable, and that's the two numerators. The denominators are already equal. Nothing's going on there. You don't even need them. So this is essentially the equation that you have to solve right now. And you're going to see that again in a minute. So if you do all that work, all you have to do is set the two numerators equal. And I want you to see how you're going to get to this point without doing all of this stuff. Okay? I was interested in Diego's solution. He has x plus 1 over 4. And then if you simplify the top, it's 5, I think, minus 2x over 6. Cool. A lot of students get here, they have no idea what to do because we're not well versed in US pedagogy with proportions. Anytime you have any two equal fractions like this, it's an equation, those two fractions are equal, this is what we call a proportion. So one way to solve this is, one way is to multiply this side by 24 and this side by 24 and get rid of this, but another way to do it, put your parentheses, is to use your cross products idea, which is always true when you have proportion. It's always a way you can solve it. So 6 times x plus 1 equals 4 times 5x minus 2x. I don't think it's 5x. It's 5. Yeah, it's just 5. And that's what Diego did. So that was kind of cool to see that. So as you can see, there's a lot going on here. And I know you want me to tell you what to do. I can tell you what I think is the easiest thing to do, but you're probably going to fall back on your old habits. And no matter, if I got up here and did a song and dance, not only would I be embarrassed, but you tend not to want to do the easier route here. The easier route here is this, right here, these steps. So do you agree that it's easier to solve linear equations without fractions in them? Do you agree with that question? Yes? No? Yeah. Would you like to see on your quiz on Monday equations without fractions? Yeah. So if I give you an equation with fractions in them, get rid of the fractions. Don't deal with them. And how do you get rid of the fraction? It's the same idea almost. When we find that number 12 and we're adding and subtracting things, we call it the least common denominator. And we create equivalent denominators and then the equivalent numerator to that original fraction. Okay, so we're still taking that number 12, but its role is going to change. That's the only difference. So now I'm going to call 12 the least common multiple because I'm going to multiply, multiply. That's where it comes from. Everything in the equation by 12. So there's two things going on here. Because I have an equation, I have a very powerful tool available to me that I don't have if I cover up the left-hand side of that with my hand. If I just have the right-hand side, that expression, no choice. I have to change them to equivalent fractions with the denominator of 12, 24, 20, 48, 1200 if you want. I don't care. If I have an equation, I have the right now because I have both sides to multiply by any non-zero quantity. I'm going to pick 12. I could pick 2400 if I wanted. I want my work to be as limited as possible, so I pick the smallest common multiple to 4, 6, and 3. Now I'm going to show you how to get this multiple with numbers so that when you see it with algebra, you can try to make the relationship. You wouldn't do this because you're all aware of how to do this with numbers, but this is really what you're doing. You're finding the prime factors of each number. This is already prime. And you're creating the smallest multiple. So the smallest multiple, I'm going to show you how to do this with circles. Okay, so you see here, here's the number 4. Here's the number 6, 2 times 3, but I borrowed this 2 because it was already there. Then here's the number 3. So the multiple's right here, straight across, 2 times 2 times 3, it's 12. So I'm going to multiply both sides of this equation. Here's first strategy for any algebra class. Whenever you have a numerator that has more than one term in it, meaning you have an adding and subtracting in the numerator, put it in parentheses. It's not going to be that important here because you have a plus sign, but as all of you realized in the first problem 1a, you forgot to distribute, some of you, that subtraction sign. Put it in parentheses. So this is now what I have. I have this on the left side, and I have, notice my 12 is going to go in beside each and every term that I see here. I have 1/6 as a term here, and then that fraction as my second term. Notice my language terms, and then 2x minus 2 minus x over 3. Now, this is why I gave you the first problem in 1a. When you have something like this, it doesn't matter. This 4 can move around. It's in the denominator. You could put that 4 under that 12 and call it 3. It doesn't matter. This is multiplication. So it could be 12 over 1 times x plus 1 over 4, or it could be 12 over 4 times x plus 1. It doesn't matter. This 4 is a factor of 12. That's why you chose 12. So you have 3 times x plus 1. This 6, cool, cancels into this 12, and that leaves you with a 2. And this 3 here cancels into this 12 and gives you a 4. Lo and behold, you have now changed your ugly looking thing with fractions in it to a linear equation that you could have solved before you even got into an intermediate algebra class. So you don't like these fractions? Get rid of them. How? Multiply both sides by a multiple. And from here, I think it should hopefully be something that you can all solve. 3x plus 3 equals 2 plus 8 minus 4x. 3x plus 3 equals 10 minus 4x. I told you I would come back to this. So go back to the previous page. Here it is. Those are your two numerators. So why go through all this ugliness just to get to exactly the same spot you can arrive at by eliminating them? So from here, you solve the equation 7x equals 7, x equals 1. In this class, on your homework, you're going to be asked to find solution sets. What is the solution set? Anytime you have a set that's finite, you use your roster method. Your roster method was like the method we used to talk about the Beatles. Since there were only 4 Beatles, we could list each member of that set. Because we have one answer, this is the solution set. This is what my math lab is going to be looking for. I saw some of you do this. You use the set builder. If you did this on a test, that's fine with me. Because it's a fancy way of writing a one element set. But there's nothing incorrect with that. But this is what your homework's going to be looking for. So I just wanted to point that out to you. Okay? So the moral of the story is, if you have an equation where you have rational expressions, meaning you have fractions in them, you want to find the common multiple, and instead of changing everything to common denominators, you want to use that multiple by multiplying everything on both sides of the equation. And in effect, you are creating common denominators. What's in the denominator is 1. That makes it a lovely looking fraction equation. All right. Now, you see this thing I did right here with primes? You probably, because you know, oh, I know 12, 6 goes into 12 and 4 goes, you probably never looked at this very much. However, this idea I just showed you is exactly how you find the lowest common multiple when this happens. You have these kind of denominators. So these are the denominators we're going to be working with today. I'm going to do one of these for you, and then you're going to have the rest of the period. So the denominators we just looked at had constants in the denominator. The constant numbers 4, 6, and 3. Now we're going to learn how to solve rational equations like this. And what I want to say to you is they're not really that much different. Once you understand the idea behind finding a common multiple, it's exactly the same process. So what you need to do is, if this is where you left off in intermediate algebra last semester or the semester before, this was the end of the semester and it was yucky hard stuff, spend some time just looking at the ideas with this problem and then try to translate them to this problem. So Zach, you want to read this for us, the procedure? No, Zach, today? Parker, you want to read it for us? Yeah, the procedure, where it says the procedure. So the very first thing you want to look at is you want to say what values of x will make these two denominators equal to 0. And the only way you can do that is by making sure each denominator is completely factored. So this first denominator is what we call prime, x. You can't factor that. So what value of x will make that 0? 0. It's almost like a silly question. So the excluded values, and this is kind of an awkward thing. You say what x equals because that's the excluded values, or x cannot equal. So it's kind of like a weird thing here. X can't equal 0. So 0 is excluded from the solution set. We don't know what the solution set is yet, but there's no way a 0 can appear in there. And if it does, then you knock it off. You say that can't possibly be the answer. Now, what about this next thing? Factor it. So before you do any work on these equations, factor all denominators. That's going to be your first chore, okay, is to factor all denominators. So the first denominator here is already prime. X is prime. It gets its own circle over here. Here's my circle with x in it. Anybody remember how I'm going to factor this second one here, x squared minus x? Greatest common factor. Remember I told you, put it on your palm. In fact, maybe that's what my tattoo will say. So, no, I'm not that boring. X and then x minus 1. But I'm actually going to make that a different color. So do you see you have two different factors here? The blue factor x, you've already taken care of over here. That's already in its circle. No need to write it again. No need to duplicate. We didn't duplicate John and Paul in the reunion, okay, or George. Now, is there a different factor going on here? Yep. So it needs its own circle. Okay. And you say, oh, wait a minute. This denominator, though, also has the x in it. So you say, all right, I'm just going to overlap with my first circle and get that x in there. So here we go. There's my first denominator in the blue circle, and my second denominator is going to borrow the x from my first circle and then create a new color, red, to represent the x minus 1. So now to find your smallest multiple, I agree. You could multiply x times x minus 1 and get a multiple. But you want the smallest because you don't want all this like funky cubes and fourths and these, you know, if you don't get the smallest multiple, you can wind up with a really big equation with lots of higher power variables than you need, exponents. Here's your multiple right here, x times x minus 1. So I'm going to now multiply both sides of this equation by the lowest common multiple, which I just found right here, common. This little visual works all the time. X times x minus 1. So that's what I'm going to do. Here we go, and I've got to keep changing my colors. I'm going to multiply this first fraction times by x times x minus 1. Notice that denominator is 1. And I'm going to multiply it by 1 over x. My second fraction is 1 over x times x minus 1. And I'm going to multiply it by x times x minus 1. And then finally, on the right-hand side, I just have the number 5, which sits on top of 1. And I'm going to multiply that whole thing by x times x minus 1. Okay, so here's the really powerful part. The powerful part comes right now, where each of these denominators will be a common factor with that multiple, because you've created it that way. You're like master manipulator right now. You've manipulated this equation to get rid of those denominators and make them all 1. So all you're left with in this very first term, when you do all that multiplication, is just x minus 1. That's it. Cool. Second term right here, what happens? Your x cancels with a common factor, and your x minus 1 cancels. What are you left with? 1. Wow. And then on the right-hand side, you have 5 times x minus 1. So if I give you this equation, you're probably much happier to see something like that than you are what we started out with. So the 1's cancel here, and you get an x on this side, and you use your distributive property here, and you get 5x squared minus 5x. You now have a quadratic equation to solve. So now you say, uh-oh, my solution set may have a possibility of 2 answers. So now I might have 2 answers in my solution set because I see I have a quadratic. So to solve this quadratic, you got to get a 0 on one side. So I'm going to subtract x from the left side and the right side. I get 0 equals 5x squared minus 6x. And to solve this quadratic equation, I want to factor the right-hand side using my greatest common factor of x. I pull my x out front, and I have 5x minus 6. And I set my 2 factors equal to 0, and I solve. And if both of these were legitimate answers, I would have to put the smallest number first in the solution set, always smaller number first, and my larger number second. However, what is wrong with doing that as a solution set? Right, at the very first step, I said there's no way x could equal 0. It's not part of this clique. It's never going to make it in the door to this fancy club because it makes your denominator 0. So this is what we call extraneous. It's not part of the solution set. So your solution set is simply the number 6/5. Okay. So you have 15 minutes, 17 minutes to work on the exercises. A lot's going on today. If your head's a little fuzzy, it should be. I would suggest looking over 1A and B and maybe going to the problem you think you might have the most difficulty with, but hopefully you'll be able to get a good start on both of them and maybe finish them, okay, before you leave. Please raise your flags if you have any questions at all. I'll be glad to help you out.